All right, who is ready to talk about the quadratic formula and discriminant? Section 3.2, let's go. Starting off with the quadratic formula. That is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now the discriminant is just part of that. That is just the b squared minus 4ac part. A couple of things the discriminant does is it'll tell you, one thing the discriminant does is it'll tell you how many solutions you'll have. So if you find your discriminant and it's positive, then you will have two real solutions. If you find your discriminant and it's a negative number, you will have two imaginary solutions. And if you find your discriminant and it is exactly 0, then you have one real solution. So let's put both of these to work. So the directions say to find the number of solutions by using the discriminant, then solve using the quadratic formula. Before you begin, you need to make sure that these equations equal 0. In this case, we can do that pretty quickly by subtracting 1 from both sides. So we will have x squared plus 3x minus 1 equals 0. Now we can go ahead and label A, B, and C. And just a quick note, A is the coefficient in front of x squared, B is the coefficient in front of x, and C is the constant. You can think of it like constant. It is the number without a variable beside it. So the discriminant is b squared minus 4 times a times c. So plugging in the values, b is 3, so 3 squared minus 4 times a is 1. It's the number in front of x squared there, which is 1, times c, which is negative 1. So simplifying, 9 minus 4 times 1 times negative 1 is negative 4. Two negative signs back to back like that turn into addition. 9 plus 4 is 13. So my discriminant is positive, which means we will have two real solutions. I'm just quickly sketching what that might look like. Here's one solution. Here's two solutions. Okay, actually finding the solutions, though, we need to use the quadratic formula. So go ahead and write that down. Negative b plus or minus the square root of b squared minus 4ac all over 2 times a. We might have to sing that in class. I think that sounds like a great idea. That song is just stuck in my head every time I say it. It's hard not to sing it. So plugging in the values now. B is, we have negative and then 3 plus or minus the square root of, we did this part already, but I'll fill in the values first. 3 squared minus 4 times 1 times negative 1. It's a and c divided by 2 times 1. All right, so we can clean this up. So negative 3 plus or minus, like I said, we did this part already right there. So we know what the discriminant is. It's just 13 divided by 2. So cleaning this up, let's see, we can't simplify the square root of 13. There's no division, so our two answers are going to be this. X is going to equal negative 3 plus the square root of 13 divided by 2, and negative 3 minus the square root of 13 divided by 2. And those would be our two real answers. Sometimes they're not very nice numbers like this one, and we just kind of deal with it. Other times you get like 5 and negative 4, like super easy answers, easy to make sense of. So we got one more example here. The exact same directions. Find the number of solutions first by using the discriminant, and then actually tell me what the answers are. So again, we want this equation to equal 0. The quickest way to get that done is going to be by subtracting x squared from both sides. So 0 equals negative x squared plus 2x minus 5. Again, I'll label A, B, and C. Here's A, here's B, and C. And let's first start by using the discriminant to figure out how many solutions should we end up with. So b squared minus 4ac. b is 2, A is -1 and C is -5. 2 squared is 4 minus 4 times -1 is -4 times -5 here is positive 20. 4 minus 20 is -16. So that means our discriminant is negative, which means we will have 2 imaginary solutions. So something like this, where I get 2 answers, but they're not real because they don't, the graph is never going to cross the x-axis here. The x-axis is where you get your real solutions from. Anytime you don't cross the x-axis, we don't get real solutions. All right, let's go ahead and find those actual solutions by using the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Plugging in the numbers, negative and then 2 plus or minus the square root of, we did this part already, but again, I'll fill in the numbers. 2 squared minus 4 times -1 times -5 all over 2 times -1. All right, so x equals -2 plus or minus. We found this part again. We found the discriminant. It's right here. It's -16. So I can plug -16 in back underneath the radical divided by -2. Now here's where those imaginary numbers come into play. If you saw the square root of -16, you would tell me that there's no solution. But there is a solution. There's actually 2 solutions, and they are imaginary. So that means we're going to introduce imaginary numbers, or the I. So the square root of 16 is 4, so that means the square root of, I'm going to hop over here quick, square root of -16 is 4i. Divide that by -2. Okay, so if you can take the square root of this, if you can take the square root of that number, always do. The last example, there's nothing we could do with 13 there. We can take the square root of -16 though, and then once you get to this step, you are going to end up with some division that you can do. We can divide these two. -2 divided by -2 is 1. We can also go this way. 4i divided by -2. Oh, excuse me. 4i divided by -2 is just, well, I guess it doesn't matter because the plus or minus in front of it, but it's just going to be 2i. So plus or minus 2i. Yeah, okay. Cleaning this up, well, I guess really you could circle your answer like that. That's fine. If you want to write it out as 2 separate answers, it's going to look like this. X equals 1 plus 2i and 1 minus 2i. Same thing. Both of these are acceptable answers. And that's it. So there's 1, 2, 3 I would like you to take a look at. First, make sure that they're equal to 0. Then go ahead, use the discriminant to figure out how many solutions you should get, and then solve it to figure out what the actual solutions are. And that's it.